Hi, welcome to GlitterPoint. Before giving you a real-time demo of our solution, let me brief you what we do at GlitterPoint. We are an IoT solutions company. We build software solutions that will connect the physical assets to the cloud, and help the asset owners to monitor their assets in real time. We work with asset-intensive companies from manufacturing, both discrete and process-intensive. Energy companies, be it in wind or solar. Companies from logistics, transportation and fleet. Mining and oil and gas companies. Original equipment manufacturers, to help them monitor their assets' health in real time, so that they can reduce equipment downtime, improve asset health, and productivity as well. Our software solution, built on technologies such as machine learning and big data framework, consumes data that is being produced by these machines in real time, understand the patterns in the data, predicts the failure of the machine or predicts the possible drop in efficiency, and alerts the operational and maintenance team. This helps the O&M team to take proactive action and prevents unscheduled downtimes. Our solution helps to reduce equipment downtime, improve asset health, increase productivity, improve quality of the products. Irrespective of the industry, our solution is very well poised to save 25 to 30% of the maintenance costs. Let me show you a demo on how our solution actually works.
Let me show you how our solution works in real time. Birds fly by pushing air. Mankind made many things that push air, but one of the greatest machines that push air is the jet engines. We at GlitterPoint build solutions to monitor robust engines like this and diverse assets to help companies improve their assets' health and reduce operational costs. Let us see how we monitor the health of an aircraft turbo engine in real time. Here is our aircraft engine. Basically, in any aircraft engine, a fan at the front sucks the cold air into the engine and forces it through the inlet. A second fan, called a compressor, squeezes the air by about 8 to 10 times, and this dramatically increases the temperatures of the air which entered. Then the liquid fuel is squirted into the engine from a fuel tank in the airplane's wing. So in the combustion chamber, which is roughly placed here, which is right behind the compression, the fuel mixes with the compressed air and burns fiercely, giving off exhaust gases and producing a huge increase in temperature. These exhaust gases exit the engine through a tampering exhaust nozzle. The hot air leaving the engine at the back is traveling over twice the speed of the cold air which entered it at the front, and that's what powers the whole airplane to fly. So inside any working aircraft engine, critical attributes such as temperatures, pressures, fuel flow rate, etc. will vary with time. All these attributes should be within allowable limits. If not, the efficiency of the engine starts reducing, which means the fuel consumption will start increasing. Remember that the fuel comprises of 40% of the operational cost to any airplane company. Also, the suboptimal functioning of the engine causes severe wear and tear that reduces the life of the engine. Let us see how we monitor the health of the engine and can help to maintain the engine efficient. So for this, we have simulated a runtime failure data of 100 engines with all the key attributes such as temperature, pressure, fan speeds, fuel flow ratio, and build a machine learning model which is nothing but a combination of mathematical functions that can understand the past behavior of aircraft's functioning. Our solution captures the real-time data of the engine and streams the data to the machine learning model. Our machine learning model identifies if there is any degradation in the machine's health and gives warning advisory. The whole story will be shown in the dashboard in real time. So this dashboard will be embedded in a web or mobile application which will be consumed by the field engineers. Now let's go to the dashboard. The dashboard provides a consolidated view of critical engine systems and status such as the remaining useful life, which means the remaining life of the engine before it fails, and fuel flow ratio, which indicates whether the engine consumes the fuel efficiently or not. Here, the decrease in the value of fuel flow ratio indicating the degradation of machine's health. These fuel flow ratio values, colored in green, indicate the engine is working normally. Yellow color indicates that the machine health started degrading. And the red color indicates that the engine is in critical condition and requires immediate attention. Below here, the health status of the engine can be monitored constantly, and if the machine health is below 60 cycles, remaining useful life of 60 cycles, then a warning advisory will be shown here. If the machine's health is less than 30 life cycles, and a critical advisory will be shown here. And you can see here that if the machine health is dropping below 60 life cycles, then a warning sign is appearing here. You can also see the information about the key indicators of the engine's health. The temperatures are reaching threshold value, and the warning sign is appearing here in real time. Here the pressures of our critical systems are well above the threshold. When the values are reaching the threshold, then a warning sign is shown here. So this real-time streaming information helps the field staff take proactive actions. In totality, our solution helps us to constantly monitor engine's health for efficient operations. Not only aircraft engines, our solution can also be extended to predicting failures and inefficiencies in wind turbines, manufacturing plants, heavy construction equipment, power plants, inefficiencies in logistics, fleet, etc. Do follow us at www.glitterpointcorp.com, where we are posting interesting stuff about technologies like big data, machine learning, and IoT. Contact us to know how we can help you to bring efficiencies in your operations and reduce costs. Thank you.